Okay, so question 2 on paper 1. This time it looks like we're going to be talking about density. Indeed, we're going to be talking quite a lot about density. So a group of students wants to find out the density of the object shown in figure 1. We are given a key, an aluminium block, a toy car, a regular wooden block, and we're then asked for 2.1, which unit is used to measure density? Well, density is how heavy something is per unit volume. Mass per unit volume. How many kilograms are there per, say, meter squared? Let's have a look. Meters per centimeter squared? No, that's not mass per unit volume. Newtons per kilogram? Certainly not. Kilograms per meter cubed? That's what I just said, and that last one is unit for acceleration. Describe a method that can be used to calculate the density of the objects in figure 1. You should include the equipment required, what would be measured, and any calculations needed. 6 marks here. So, let's have a look at what we've got. A key, a regular aluminium block, a toy car, and a regular wooden block. Now, I always start, when I have to plan investigation, with the idea of what's my goal here? Well, my goal was describe a method that could be used to calculate the density. So I'm just going to go back onto here. I know, because I've learnt this equation, that the density of something is equal to its mass divided by its volume. In fact, you might notice that was kind of hidden in our definition there, mass per unit volume. Therefore, if I want to work out the density of these objects at the top, I am going to need to find the mass and also the volume. Mass is fairly easy to obtain. You might say, oh, well, we can use some weighing scales. I'd say, let's use a proper scientific name for this piece of equipment. We are going to find the mass by weighing them on a top pan balance. This is what you've used in labs for physics and chemistry and possibly biology too. That little, it's basically a mass balance, and on top it has a little pan in which you can put whatever you're weighing in. So you call it a top pan balance. That's how we get the mass. That works for all of those objects there. I can just weigh them using my top pan balance. However, the volume I can't obtain for all of these objects in the same way. Some of them, perhaps you've realized, are easier than others. This one here and this one here. Why so? Well, they're regular blocks, whereas these objects, the key and a toy car, are irregular. They don't have an easily definable shape. We know that the volume of a block like this, a cube or a cylinder, can be calculated by doing length times width times height. For example, if this regular wooden block here was 2 centimeters by 2 centimeters by 2 centimeters, its volume would be 2 times 2 times 2, or 8 centimeters cubed in the case of that block there. What would I need to do that? Well, for those 2 blocks, all I'm going to need is a ruler, provided that they're relatively small. So that's how I can do it for those 2 blocks. On the other hand, for the key and the toy car, I need a different method of measuring their volume. There are 2 methods available to you for doing this. Either you use a measuring cylinder, or a beaker, really. Measuring cylinder or beaker. Why a beaker instead of a measuring cylinder? Provided it's got enough graduation, so the beaker's a bit larger. And secondly, you need a, the other option is something called a Eureka can. And you would need a Eureka can plus a measuring cylinder. I shall explain why. Okay, so let's have a look at how this works first of all for the measuring cylinder / beaker. I've got a key or a toy car and I'm looking to find out its volume. What I'm going to do is I'm going to get my measuring cylinder and I am going to fill it up with water, like so. Not all the way, just to a certain point. Then I'm going to read the level on the side. So let's say this is, let's go for 15 centimeters cubed. I will record that value. Then I will add, for example, let's pick on the key. Shall try drawing a key. No, it's just about worked. It doesn't like that for some reason. This will have to do for my key. There's my key. I'm going to drop that in the water. I'm sure you recognize that when I drop that key in the water level is going to rise. How much does it rise? Well, usefully that water level is going to rise by the volume of the key. Therefore, the difference between my old reading of 15 centimeters cubed and my new reading, say it goes up to 20 centimeters cubed, is the volume of my key. So my key is 5 centimeters cubed in this case. That's how I'd use a measuring cylinder or beaker to do that with water. But there is another method, and perhaps you remember doing this when you were back in year 9. We use something called a Eureka can. Now, a Eureka can looks somewhat like this. It's a little silver metal can, and you can fill it up with water, and that is exactly what we do. We fill it up with water to this point here. I just cut that's a spout here. You need to fill it up all the way to the bottom of the spout, and you need to say that as well. You're filling this can to the bottom of its spout. In fact, I'm going to make sure that's clear by colouring it all in blue there. Now, much like last time when we added the key into the water, when we drop the key into here, it's going to displace water as well. Only this time, because we filled it up to the bottom of the spout, the water is going to pour out. Cleverly, if we leave a measuring cylinder underneath here, we can very easily measure how much water pours out. So once we drop in the key or the toy car, if I draw a little toy car in here, and perhaps you manage to find a Eureka can that fits it, the water will pour out and you will read off your measuring cylinder. How much water has poured out. So say its volume is 10 centimeters cubed. So in summary, to work out the density of something, you need to find its mass by weighing it on a top pan balance. That is the correct term. And you need to find out its volume using one of two methods. Either you can use the measuring cylinder or beaker, or the Eureka can measuring cylinder for an irregular object, or if you have a regular object like a cube or a cuboid of some sort, you are going to use its length times width times height, and you will measure those things with a ruler. We'll have a look at, I'll write up that 6-mark answer for you in a second. I will talk through it. You're more welcome to just skip through it though. Skip to the end, have a look at what I've written, have a look at the mark scheme you're going to be given to. I'm just thinking, are there any other points I ought to make here? Oh, okay, so the last thing I should add about that is, why can't you just say, well, use the Eureka can for all of them, or the measuring cylinder for all of them? Why do you need to use the ruler method? Well, the only thing I could think about there is one of your blocks is wooden. Your wooden block floats, therefore you wouldn't be able to measure its volume by dropping it into water. Right, moving on. So I'm going to quickly go through this 6-marker and write an answer to it myself. So describe a method that could be used to calculate the density of the objects in figure 1. You should include the equipment, what would be measured, and any calculations needed. So what I'm going to start off with by saying is to calculate density, we must find the mass and volume of each object. I probably didn't need to write that. This has just helped me frame my answer. And then I'm going to go through these in simple steps. So I'm a stickler for this. Write a numbered method. It helps you order your thoughts, and it helps the examiner see your thoughts are ordered too. So number 1, find, I always start with a verb, find the mass of each object with a, you can remember what that's called, top pan balance. Find the mass of each object with the top pan balance. Or you might say record the mass of each object from the top pan balance. 2, so now we've got the mass of all objects. Find the, or we should really say, measure the length, width and height of the wooden blocks and multiply them to find their volume or volumes. I really probably should have written length times width times height as well. There we go. Now, as I said, that method wouldn't work for the irregular object, so I need to write something slightly different for that. So 3, let's say fill a Eureka can to the spout with water. Fill a Eureka can to the spout with water and place measuring cylinder beneath spout. 4, drop in irregular objects, that's the key and car, and measure or record, again I should have said, volume or read perhaps of displaced water. That's the water from in the measuring cylinder. Okay. And lastly, 5, calculate densities using, and this is always an important step, density equals mass over volume. Always tell your examiner what equation you're going to be using to do this. Okay, that's the 6-mark answer there. That would get me 6 marks. I really hope. You can have a look at the mark scheme, perhaps mark my answer. How did I do? 2.3. Explain how the density of water changes when it is heated. Notice the command word here, explain. It doesn't just want you to say it goes up or it goes down. It wants you to explain why it goes up or down. So, explain how the density of water changes when it's heated. Let's have a look. So firstly, I'm going to say the density of water falls as it is heated. That's my first statement. There's a mark for that. Now I'm going to go into the explanation. Why does the density of water fall? Well, as it's heated, I'm going to, therefore, and I should have is a because in this, as it's an explain question. Because particles gain more energy and their separation increases. So as the particles gain more energy, they vibrate more strongly and their separation increases, as opposed to a cooler liquid where liquid particles might be vibrating quite near to each other. They have a slightly larger separation when they warm up. Now that's the key thing. Because particles gain more energy and their separation increases, therefore they occupy a greater volume for the same mass. We've got the same mass because we've got the same number of particles, but because they're a bit more separated, the volume's increased. And density equals mass over volume. You don't need this last bit. That would be a fine answer above. If your mass is staying the same at the top and your volume is increasing, well, your density must decrease because you're dividing by a larger number. Good, that's question 2. I'm not going through question 3 because it's about radioactivity and this is something you will not be examined on. So that was the next 3-4 pages.